cadets on camera today. Can I get a voice check from you guys just so that I know you're on and around?
Hey, sir.
And you, sir.
Are your guys' cameras on?
Mine is.
There you go. I just need, yeah. I don't know why. Until I check, I don't ever see it. So I see Richard. The other two guys just double check on there. I don't need you guys audio on or anything like that, and I'm not going to hold you guys responsible for anything. Then your guys' job is just to represent the feelings of the entire class. So if you feel that the other 24 cadets are confused, I need you to look confused. I understand that Richard gets absolutely everything I'm talking about. So if you look confused or surprised, I assume that's you trying to represent all your other wingmen there. And then what do we got? Grayson, Brooke, I'm gonna see if I, just because, why am I not seeing you guys? Maybe because I got too many. Can you guys say something on here and make sure I got you?
Yes, sir. My camera's on.
There we go. All right, now I can see you. So weird. Okay, cool. We are good to go. Again, I apologize for the burrito, but I was crashing at the end of M1. As a trade-off, you guys are free to eat as well. All I ask is that if you guys see me choke on camera and fall down, just send a message to my boss, okay? Okay, so quick admin item I'm going to be sending out at the end of each class. Who are my 3 cadet on camera for the next semester, or next class? Just helps me inordinately so I can see some faces, I literally last semester twice ran into like some of my cadets at Chipotle, and I was coming home picking up dinner after class, so I still had my uniform on, and you guys see me all the time, so they're like, hey, Colonel Richards, and I was like, hey, it's you. You're very important people who I care about and totally recognize in civilian clothes with masks on when I've never actually seen you on video. So I started to realize that I didn't know what any of y'all looked like. So I'm trying to put that together to do better, and we're getting there. So I'm going to do, once again, I'm going to bring up my chat here, and then I'm going to dismiss that, and then we're going to device gallery, together mode, full screen, call me, turn, or whatever, I don't care. Okay. Where am I going with this? Today we're doing, we got lesson 2, guided lesson 2. And as a reminder, a couple of admin things. We have the guided lessons posted up on the all students. And that is the whole idea of this is that you guys read through the guided lesson first, not so that you just have to completely teach it on your own and understand everything. It's so you are looking at it first. And if you do understand everything, great. Then we don't have to really have class. We can just spend the whole class doing the examples or letting you guys get ahead on work, which we will definitely do sometimes. But if not, then you read it and you go, okay, I understood this 75%. I only have questions on this, so I can spend the class only on what you guys need. If you guys looked at it and go, we have no idea what was happening in there, then I have no problem lecturing for the entire class. But there's going to be a lot of times when that is not the best use of the time, right? With this being a flipped class, really, the online portion of this class is just designed to be whatever it is that you guys need is most useful to you. A couple of admin reminders. We have your first homework is due lesson 3, which is Wednesday. It's due online at 1700. It's the first one's easy. It's just like where it's like 5 questions about hey, what did it say on this page of the syllabus, just to make sure you looked at the syllabus at least once for the entire semester. The bigger thing is that lab 1 is due on, I believe, lesson 5. Someone can check that for me, but I believe lab 1 is due lesson 5. Is that, in fact, you know what? Let's check that together. So if I go into here and I go to the teams and I go to all students, and I'm going to go to the files, and I go to the class materials, and I go to, I wait for MissionNet, I go to admin documents, and I go to the welcome package. This should open up in here, and you can, if this was to load, in theory, I could scroll down, there we go, and I can go down and see all those great pictures. And I can go all the way down to here, and it will tell me, sure enough, lab 1 is due on lesson 5, which for us, because of the holiday on Monday, is going to be next Tuesday. So that one is not particularly difficult, but it is a little bit lengthy just because it's our first one. So even if you aren't going to start doing stuff till later, I would recommend opening up, making sure you can get the stuff for lab 1 and look at it and read through it at least like today or tomorrow, just so you get an idea of like, okay, this could take me X amount of time, so that you have an idea of how much time. Also, it's convenient because the sooner you look at it, the sooner you can ask questions either of me or on the collaboration on here of your fellow cadets. Because if you ask me on Wednesday, hey, I don't know how to do this, I can show you real easy. If you ask me Monday night at midnight, I'm less likely to be available to answer questions. While we're in here, I wanted to point something out just as a reminder to you guys. So this is the kind of outline that shows when everything, what lesson everything is due on. But I highly suggest you guys scroll down to this next part, because this here is the, these are the lesson objectives for each lesson. When you read the guided lesson, these are listed at the top of every lesson. So these right here would be listed at the top of the guided lesson for lesson 2 that in theory you guys looked at before you came to class. These are important just because these are the best way I can suggest that you study or kind of take notes during the class, because these are literally the 5 things that I expect you to get out of the course or out of the class, right? And when I write a quiz or the GR or the final, this is literally how I do it. Like if I say, hey, GR1 has to cover block 1, then everything on this page, these are all the objectives for block 1. So what I do is I literally pick, if say GR1 is going to have 20 questions, I go through here and I pick 20 lesson objectives, and then I build a question off of that. So I might say, hey, this one says for today, given a scenario, identify the sampling methodology that's most appropriate to use. And go, okay, so that was a lesson objective. So I'm going to make question 1 on the GR maybe be, hey, here's a scenario, and then it's going to be A, B, C, D. Which of these is the best way sampling methodology for this scenario, right? And so A, you can use this as your notes, but B, it's also a kind of way of saying when you're going back and studying or looking at, like when we get to lesson 5, in theory, you should know how to do everything on lesson 4. So if you look at something like explain how the law of large numbers applies to probability, if you don't even know what you're like, I never heard of the law of large numbers, go back into the guided lesson, and the guided lesson should kind of show you what section that was supposed to be in. If you read that and it doesn't jog your memory, then the next step is to ask me and be like, sir, what does that mean? Explain how the law of large numbers applies to probability. And I can send you back, oh, it'd be kind of like this type of question. You'd be like, oh, that's easy. I didn't think that's what you meant. Cool. I'm good to go on that. And then you're good, right? There's also some things on here that, because this class is fully like open note, open everything, you do not need to memorize all this. I'm the course director for this, and I don't have all of this memorized, right? There's no reason, like, I've had to forget my child's birthday in order to fit some of this stuff in my head, right? So I don't need to push more on there. Not to mention, I've got this weird thing going on in my brain where I don't really get a say all the time in what goes into long-term memory. Like, I know all the lyrics to Vanilla Ice's Ice Ice Baby. I know the license plate of my third grade principal was 704 AES. I can sing the entire periodic table of the elements, but I don't know my father's birthday. It's somewhere in the end of January. So things get popped in and out. That's not that's just an issue I've had to live with, right? So if you're anything like that, then like I had a cadet last semester who what she did was she used this and put this in an Excel sheet and literally like kind of put page numbers or notes to herself and said, hey, law of large numbers, that's on page, I don't know, 62, right? So she's got it mostly memorized, but then when it comes up, if she needs a jog, she can just jump to that page. If you guys are interested, our textbook is a PDF. You can literally add bookmarks to the PDF, right? There's bookmarks on the left for the chapters, but you can add your own. So I had one cadet who went through and just made their own annotated version of the PDF, which honestly, they probably could have made money on selling that to you guys. But it was just like for every lesson objective she had a note so she could just jump to a section on there. You can even make post-its in that PDF as well to make comments, say circle right here, hey, this is that thing we did, I made code on that, whatever, right? So use that as your people always ask me like, what should I study, how should I study? This is my best advice on where to start. I know we're like 15 minutes in class. We haven't actually talked about anything in the class, but it's a relatively light lesson. And I wanted to hit this stuff. Any question about anything you guys are seeing in here? Sorry, it's a very chewy burrito. Okay, so let's go back to actual lesson for today. So keeping with what I was kind of trying to say before I go into any of my spiel about introduction to data, anyone who looked through the guided lesson, anyone have any particular questions of things that stood out or were confusing or clarifications that they wanted on that lesson? Yes, no, maybe so?
Sir?
Yeah.
Go on, Matt.
Yes, sir. So it both in the video and in the lesson, it kind of defines the types of variables into like 4 different categories. But do we need to, like, would we ever actually need to be like, if you say, colors, we need to be able to like tell you what type of variable that is, or is it more just to like raise our awareness of different types of data?
I was hoping that question was going to be more involved so I could eat more of my breakfast. No, you mostly hit it on the head. So yes, the types of data, and this is one of those things where the videos were a little bit different than how the book did it. Neither of them like contradict the other person, but I do want to make sure I take the moment to say, when in doubt of terminology, the book is going to be our Bible. It's not always the best, but I want to have one place where if there's a confusion on what we're using, that we're you guys know what to go with. So I'm going to go with the book. And so this is the breakout of the book. So yes, on the one hand, you do need to know what a categorical variable is versus a numeric data, right? I'm not going to ask you to write a definition, but I might say, here's an example. Here's a variable. Is it, and then there'll be multiple choice. Is it numerical, categorical, right? But it also might be it might also be like a multiple answer where it says, here is a variable. Select all that apply, categorical, numerical, discrete, right? And you might say, okay, well, it's numerical, but it's also discrete, but it's definitely not categorical, right? So a lot of what we're going to do in this class has to do with you being able to identify and recognize things, whether saying, identify what is the type of variable, or identify, here's a scenario, what type of variable should I use, or what type of distribution should I use, or what is the right thing in this situation. So to kind of answer your original question, yeah, the main point is to raise awareness, but not like raise awareness of like when they have a concert to raise awareness for something and all they do is create a bunch of garbage out in the middle of the desert and 5 bands play and nothing changes about whatever disease they were raising awareness for because everyone else already knew about it. I mean, raise awareness in the way of saying, like when we talk about numerical and continuous and discrete, right? To understand that not all numbers are created equally, right? Because throughout this, and not all variables, because throughout this class, you're going to be taking data and doing things with it. And one of the things that is really important for you guys to understand is when I give you data, to be able to know what you can and can't do with it, right? So when you talk about categorical and numbers, for example, you might get a data set where one of the variables is month, right? And month is stored as a number, 1 through 12, right? And so, yes, that is a number, but it's important that you understand, well, it's a number, but it's not really a number, right? January times 2 isn't February. That doesn't make sense, right? And so, really, those are they're numbers, but they're really categorical because it's almost the same as saying, my cars are red, blue, green, or yellow, and the month that they were released in were January, February, March, April, right? And so R will say, yeah, these are numbers. And if you say, hey, what's the average a month? R will be happy to say something like, oh, the average of month is 7.3. What I need you guys to understand is that statistic is meaningless, right? If I say the average month is 7.3, that it'd be hard pressed. Maybe you could make some meaning on it, but not really. And especially when you start getting into other things, right? February is not bigger than January, it's after January. And so understanding what, and so we're going to see things about how you can take that number in R and say, one of the things that makes R powerful is, on one thing, it's a computer program, so it's dumb. It only does what you says, but what you tell it to. But on the other hand, it's better than Excel because in Excel, I can have a list of months, and then I just got to remember those aren't really numbers. In R, I can say, hey, change the month variable to categorical type. And now I know I can do things that I would do with a categorical variable, like sort them and things like that, and say group all of them by month. But I am now not allowed to do things like averages and things like that because it's not really a number, right? Similarly, if it is a number, to understand what you can and can't do with that number, right? Like on this little chart here, we have continuous versus discrete. And most of you guys have heard that by now, but there's still some confusion sometimes of what it means, right? Continuous means exactly what it says. Like, it's continuous. No matter what 2 numbers I pick, there's something in between, right? If I talk about height is usually a continuous, or time. If I want to say, how fast did you run the 1.5 miles? That's a continuous because you did it in 1:35. I did it in 1:36, but then someone else could have done it in 1:35.5, and someone else could have done it in 1:35.521, right? And so there's a continuous spectrum that you could choose there. Discrete, on the other hand, a lot of people sometimes confuse discrete of thinking discrete means whole numbers, right? Like discrete means 1, 2, 3, 4, 5, 6, 7. And that is an example of discrete, but it's not the only thing. All discrete means is that I go from one and then I jump to another, right? If I say I'm going to measure height, but I'm going to only measure height in ½ inches, then that is now discrete because my height scale is, 70, 70.5, 71, 71.5, 72. And so that is a discrete scale because I'm jumping. There's nothing between 70 and 70 and a half, right? I could even make up a really weird discrete scale where it was like, 1, 5, 7, 8.5, 9, 10.3. That's still discrete as long as I define it and I have this scale. But the point is that I'm jumping and there's between 2 numbers that I've defined, nothing else exists, right? But But again, and then it comes down to what can I do with those numbers, right? In one of the videos, they go into a little more depth about interval or ratio numbers. And really all of that I don't need you to memorize all of those, but it just comes down to what can you and can't you do with the numbers. Just because I give you numbers and you tell MATLAB to do something and it does that have meaning, right? To do another movie quote, Jurassic Park, spend so much time worrying whether or not you could, you never spent any time deciding whether or not you should, right? And so, for example, the Richter scale, right? If you guys have ever seen that with measuring earthquakes, you can get a 4.0 on the Richter scale, and you can get an 8.0 on the Richter scale. And yes, an 8.0 earthquake is worse than a 4.0, but 4 times 2 is 8. An 8.0 on the Richter scale is not twice as strong as a 4, because that's not how the Richter scale works. The Richter scale works that a 5.0 earthquake is 10 times as strong as a 4.0 earthquake, and a 6.0 is 10 times as strong as a 5. So an 8.0 is 10 to the 4th times stronger than a 4.0, right? So as long as you understand that, then you can do the right things with your data, but you have to understand that just because you can do math doesn't mean that it means the same way. And that's really the main thing I want you to get out of this, is that understanding what numerical and categorical is. Categorical is something like colors or months or something like that. And what can you do with that? You can group by that. You can do a lot of things, but you can't take an average of color, but you can take average of numbers. And if you do take an average, it might be meaningful in this sense and not. So just be aware and use terms correctly. Don't use discrete when what you really mean is integer or vice versa. That's really the main thing I want to get. Don't get hung up of being able to say, I got to write out all the definitions. They're in the book. Like I said, keep the book and do that, but just be aware of how and when to use things. Does that kind of answer your question?
Yes, sir. Thank you.
Anyone got anything else on there? I saw another hand up. To that end, I should also say there's kind of a difference between variable types and variable relationships. And I'm kind of making up my own terms here. But one of the things the guided lesson book talks about is being able to recognize not just, numerical and categorical variables, but then it talks about things like explanatory variables and response variable. And here again is something to just understand that while a numerical variable versus categorical is it a number? Is it not? Explanatory and response have more to do with how variables are relating to each other, right? Any variable can be an explanatory or response variable. In terms of like what you guys learned in calc, you can kind of think explanatory is usually your X variable and response is the Y, right? Because basically when you call something an explanatory and response, you're trying to test if there's a relationship. Basically, can this variable explain how this variable is responding, right? So in this case, I'm trying to test, is there a relationship between how many YouTube videos I watch and what score I get on my exam, right? And so I am postulating that the number of YouTube videos I watch explains what my score is, that my score somehow responds to the number of videos I watch, right? And it doesn't matter if there really is a relationship or not. I am labeling this saying, if this is my explanatory and if this is my response, then I can look at this and say, are they dependent on each other, right? And in this case, it looks very much like they do. They're dependent or they're associated on each other, some relationship between them, right? And on a side note here, I'm going to say I just used the word dependent, which in this case means, yes, the response depends on the explanatory because there's obviously a relationship. But throughout this course, be aware that I wish I could say every word only had one meaning, but that's not true, right? Because when I say talking about something depending, I've got like at least 3 meanings. I could say the English meaning, which just is, hey, do you want to go get Chick-fil-A? I don't know, that depends. I mean, it depends on what happens this afternoon and how I'm feeling, but it doesn't actually have any scientific or technical or mathematical meanings. You're just saying like, it might depend on some things. Here, when I say the exam score depends on these 2 variables are dependent. What I'm saying is there's some relationship on them. One is reacting, is responding to them in a certain way. When we get into the next couple of lessons and we talk about probability, we will talk specifically about two events being dependent. And in that case, that is a mathematical definition that I can test of saying, if this equation is true, then they are dependent, right? So you guys are going to have to use a little bit of context to make sure that you use these words correctly and not just throwing them around, right? One of the things that made me laugh last semester was we were looking at graphs and it was a straight line, and I asked the cadet, what do you think about this graph? And he said, well, the line looks pretty normal. And I go, okay, I think you mean it looks straight, but normal to me means a bell curve, right? And so you got to be very careful about with what words we use here. Again, here, one of the other relationships, the other thing is just being aware of building your common sense and intuition, right? Because when you look at this, you go, oh, wow, it seems like, yes, exam score depends on the YouTube videos watched. But if you use any common sense, you're like, well, I mean, I would love for that to be true, but that doesn't seem to make sense, right? And so sometimes you might need to dig just a little bit deeper and say, you know, one of the other variables they talk about is a confounding variable or a lurking or hidden variable. Like, yes, they graph nicely, but is that really the dependency? And go, well, actually, I've been studying, and every 30 minutes, I watch a YouTube video so I don't get bored too much and kind of break up the monotony. So actually, I could also show, instead of number of YouTube videos watched, I could show my number of hours that I've studied versus my exam score. And that probably makes a little bit more sense, right? Because there's this confounding or lurking variable of hours studied. And really, the real relationship is that the number of hours I study explains both how many YouTube videos I watch and my exam score, right? And so it's not that YouTube videos are affecting my exam score, it's that the hours I studied did, because it's that confounding variable. And again, any variable could be an explanatory, confounding, whatever. Like I have on here numbers, but we could come up with a situation where categorical, right? Where I say, hey, the color of the page versus your score, and maybe you're colorblind, and if I show you the wrong color, you get nothing out of it because you can't tell the difference, right? So we can have different variables be explanatory response based on that. Any question on any of these relationships or things of that nature?
So I remember whenever I was reading that, like, it kind of seemed like a confounding variable was both a dependent and independent one. But is a confounding variable just one that's like one that explains a relationship but isn't directly noticeable?
More or less, yeah. You've nailed it. The confounding variable is basically something that you don't currently have in your analysis that is causing some of the relationship you're seeing. It's like we'll talk about this when we talk about causation and correlation later, but we've got like charts where I can show, hey, the number of people who die from drowning correlates very closely to the number of movies that Nicolas Cage puts out, right? And so the confounding variable in there is most likely the fact that people only drown when it's the summer, and most of his movies come out during the summer, right? So it's not that Nicolas Cage is killing people that I know of, but it is that there's a confounding variable. There's something that you haven't considered that is indirectly or directly affecting one or more of your variables or your relationships. What do we got? Just kind of, I'm going to sort through a couple of the other points on here. Population versus sample. If you guys are getting this is fine, but I do want to foot stomp a couple of things about population versus sample, because we're going to be using populations and samples a lot through the rest of the course. And this is one of those things where people get a little sloppy with their terminology sometimes. So the population, what a population is, depends on what I care about, right? So if I said, I want to know what the average height of a USAFA cadet is, right? Then my population would be all USAFA cadets, because if I could take the height of every single USAFA cadet, then I would know for certain what the average height is. I could just add up all your heights and divide by the total number of cadets, right? But if I say, dude, that would take a lot of time and I don't have that kind of resources, I'm going to take a sample, right? And so a sample is just exactly what it sounds. It's a subset of that population. I don't want it to be too small. If I just turn to one person and go, how tall are you? And they go 72 inches. And then I go, cool, I bet the average height is 72 inches. I might be right, but I'm probably wrong, right? Because it's a very small sample size. And so, but on the other hand, I don't want to sample 99%. I mean, I do, but I don't have the money or time for that, right? So it's finding a balance in between of saying, and we'll talk about this more later in the class, of how small of a sample can I take to be pretty sure that it's a good representation of the population that I want. We'll also talk about sample methods, right? Like if you just ask say, you know what, I need a sample of at least 10, and you ask 10 of your friends, how tall are you? Well, that's not going to be good either, because maybe you're a pilot and all your friends are pilots, and so you will got the average height of some pilots, but that's not representative of everyone, because pilots on general have different height requirements, right? The other thing I want to foot stomp here is, in this case, I wanted to know the average height of USAFA cadets. So USAFA cadets were my population. That doesn't mean that's all people, right? USAFA cadets are a subset of the United States population, which in turn is a subset of the world population, right? And so population isn't just a single thing. It depends what I want to know. If I wanted to know the average height of Americans, then my population would be all Americans. If I wanted to know the average height of people, that would be all 7 billion people. And in each one of those cases, then my sample becomes different, right? Because if I'm going to do a random sample, if I want to know the average height of Americans, then I literally need to randomly sample all 350 million Americans, which becomes more difficult, right? So my point being here is just to understand that your sample and population are built up of observations. So in this case, each observation is a person, right? But depending on what I care about, its population doesn't instantly mean all persons, right? It means all people that I care about in my particular thing. Maybe I only want to find out the average height of pilots. In that case, all pilots are my population. So just be aware, population and sample, what those words mean. Any questions on that? And in relation to that, we talk about 4 basic sampling methods. And again, going back to what I said before, do not waste your brain space on memorizing all this stuff. If you got the brain space, then by all means, do it. Great, you're ahead of me. But at a minimum, for something like this, mark out, hey, sampling methods, page 27. There is literally all 4 of the sampling methods we care about, with a nice example and explanation of why you would use each one, right? And now you don't have to think about it ever again, because then if a question comes up, sampling methods, you jump to 27. Read it so that you've seen it at least once before, but then dehydrate it and store it away in your brain so that later when you need to look at it, you can look at, just looking at this page will be like, dropping the water on that and be like, oh yeah, I remember, yeah, simple random, stratified, cluster, multi-stage, right? And bring that up. Otherwise, like I said, you're going to end up like me, and someone's going to ask you, hey, how do you take the derivative of this polynomial? I'll be like, oh, I don't know, but do you want to hear the countries of the world? United States, Canada, Mexico, Panama, Haiti, Jamaica, Peru. No, that's not what we asked for. Oh, okay, well, then you're useless. All right. And then the last one kind of topic I wanted to hit on was, again, this design of experiment, which was one of the objectives. And there it is again, nice summarized on page 32. But this comes down to, again, reminding you that understand context of terms, right? Because here, when we design an experiment, experiments are different than anecdotal evidence, right? Because you set out to do something and then you randomize the circumstances and made sure your data was as good as possible. And so when we're setting up an experiment, we care about things like controlling, randomization, replication, and blocking. But all of those words have very vague meaning in English, but very specific meaning when we talk about an experiment. So just understand, like, if you get a question that talks about something like, how would you, how would you better address controlling in this experiment? You have to understand that, oh, we're talking about setting up an experiment. So he means controlling with regard to how it's defined right here, not just, well, if I would control it by setting up, making sure I had officers in charge and not letting them out of the room and making sure they knew who's boss. Like, yeah, that's all controlling in the English sense of the word, but that is not controlling in the experimental design sense of the word. So just be aware of those type of terminology. Okay. Any other question on anything else that you guys saw on the lab, the learning objectives, anything like that? Or anything I've said?
Could you explain the difference between clusters and stratifications?
Yes. Looking forward to when this material gets a lot harder and your guys' questions get longer so I can actually eat full parts of my burrito. Okay. So you said, say that one more time, the difference between cluster and what?
Stratified.
Okay, so the main difference here, and I can just read it out here. So it says, in a stratified sample, it's a divide and conquer. A population is divided into so-called strata, and they're chosen for similar cases or grouped together. Then a second sampling method is used, usually simple random within each strata. So stratified sampling is the idea of saying, let's say I want to ask people their opinion on something political, and I want to make sure I know that people in different income brackets might have different opinions. So what I do is I divide the population into income brackets, and then I randomly sample within each income bracket, because I want to make sure I don't only just accidentally sample poor middle class or only upper class. I want to random sample, but I want to make sure that I get a little of each stratum, and so I divide up the stratums and then I randomly sample in between it. Cluster, on the other hand, is I take the population and I break it into clusters, and then I randomly select a number of clusters. And so stratified is I break it into stratum, and then within each stratum, I randomly select a certain number. Cluster is I say, hey, I don't have time to just do random with everyone, so I'm going to take the United States and break it into 100 clusters, and then I'm going to randomly pick 10 clusters, but whichever cluster I pick, I'm going to use everyone in that. So cluster is basically kind of like stratified, but rather than making sure I pick a random number within each strata, I pick a random number of the clusters and then use everyone in the clusters that I picked. Does that kind of make sense?
Yes, sir. And so whenever you're selecting clusters, do you have it without any regard for the demographics that you're clustering together?
You can. Sometimes it depends, but a lot of times cluster sampling comes down to saying, hey, I'm trying to balance money and time and whatnot. And so it's a little bit of a convenience sample, because a convenience sample is, oh man, there's 100 people right around me. It sure would be easy if I could just ask those 100 people. Or if I'm doing an Air Force, like, yeah, here's a real good example. If I wanted a random sampling of some opinions of Air Force people on something, truly random would be hard because the Air Force is spread all over the place. And let's say it's something where I have to give them an in-person survey. So what I might do is I might go, look, what I'm going to do is I'm going to break this into clusters of bases. And I'm going to say, hey, all my, maybe it's a question about first-term airmen. And so what I'm going to do is I'm going to break this up. And rather than saying I want random all first-term airmen across the United States, I'm going to break the first-term airmen into clusters based on their bases. And there's, 100 or so bases, and I'm going to pick 10. And then so I randomly chose those bases, but then in each one of those bases that I chose, I'm going to use all the first-term airmen. And it's convenient because they're all at that physical same location. So I randomize, so I still kind of have a random sample, but it's a little more convenient because I can go and do it one base at a time. And so that would be an instance of where I'm still trying to maintain a certain level of randomization while still embracing some convenience. But usually, but you could do a version of stratified of cluster where you're saying, hey, I'm going to each cluster is going to have some meaning, but it's actually not important that I get each one of those. I want a random sample of those. And so I'm going to then randomly select a group of those and use everyone in them. So it's usually the former, but it could be the latter. But the main difference is in a stratum, I break it up and then pick some from each stratum. Whereas cluster, I break it up and then I take a random selection of those clusters and take all of them in that cluster. That last one, multi-stage, is kind of the amalgam of the both, right? Because it says in multi-stage, it's like a cluster, but rather than keeping all the observations, I come up with a second way of doing it. So that's kind of like a cluster, but strata, where, hey, I've got all these broken up clusters that are just evenly broken up, but then rather than taking all of them, I'm going to apply a second pass to each cluster of which ones I'm going to keep.
User.
And I will tell you guys right now that when I write exams, I try to make the scenarios relatively obvious, not so obvious that I just use the word cluster, but it shouldn't be an edge case. Okay, in the last 9 or so minutes we have left, let me ask this question. Are there any of you guys, just you don't have to speak up, but just like put a thumbs up or a message in the text. Is there anyone who is still having trouble getting R installed? Have you not done that, or you're running into trouble or having problems with that? Because that's something I want to get knocked out sooner rather than later, to the point where if we still have issues with it, I'd be happy to dedicate some time next class to actually helping get that done, or in between classes. So let me know. Same with getting into My Open Math. And then with respect to the labs, I want to make sure you guys understand that if you haven't started working on the labs yet, that is fine. But I do want you guys to start looking at that soon and make sure you understand. A couple things about navigating our all students team here. Don't forget on the left here, these are these discussions and collaboration are for you guys to use, because not only is collaboration on the homework and the labs allowed, it is very much encouraged, right? So for each homework and lab, I've put a post on here for you guys to ask you just open questions. Because this is shared by all 295 cadets, and we had a lot of good feedback last semester of, literally, hey, how do you do question 5? I'm putting in this and I'm not getting this answer. Someone else, oh, didn't you see it has to be 2 decimal places? You're on the right track. You just need to add this, right? Help in there. Same thing for the labs on here, right? And working on there. The professors, we monitor this as well. And so if there's something that gets stuck, we'll also try to chime in here sometimes where we can. The files, if you guys haven't delved into here, make sure you look in the files here as well, because if you go into the files oh, I'm sorry, go to general. I went to under lab collaboration. You go to the general and you go to files. This is where we post everything for the class versus what you need, and then some of the things that are just helpful. So the admin documents, we already saw that. That's where the syllabus and things are. Guided lessons, hopefully you guys are looking there. That's where the guided lessons you're supposed to be reading through before each lesson. The instructors folder, all the instructors, anything they do for their course, we share up here because it might be good. I might just be the wrong person for you to see something. Maybe someone else does something that makes more sense. So for example, Dr. Holloway, she makes note takers for each lesson. So if that's something that helps you to kind of like guide following through, then by all means download her note takers and fill those out, and you can use those as a study aid for yourself. I myself, I put in here every PowerPoint that I show you guys, I put up here. in the next couple of lessons, I'll start to use R. I usually have a companion R program that I show how we're doing code on that, and I will post that up here as well so that you guys can use those resources. I have last semester in here. If you ever want to look at that, it's mostly the same of what we're going to do this semester, but I'll make small changes. But if you ever want to look ahead or go back, this is all of my lessons in R code and data from last semester that you're welcome to look at. The labs, this is where you guys can easily grab all of the data that you need for each of the labs. So lab 1 that's due next Tuesday, these are the 2 data files. This is the template that you're going to actually do your work in and turn in. And then the guided portion, that's the portion that you are just going to look at, that's going to basically teach you how to do your lab. Yeah, Nick, and I don't know what you go by. What do you go by?
It's Nick, sir. It's fine.
Okay.
I'll respond to either, though. You said Tuesday, but M5 is next Wednesday.
No, because there's Martin Luther King Day on Monday, so it resets.
I thought with the Martin Luther King that made the 19th a T-Day, and then...
Let me double check. I might be on crack. It happens from time to time. So if I go back, if I close this.
Of course, it says M5, yeah, on the 20th, which is a Wednesday on the calendar.
So let me see. I am learning stuff all the time. So if we go to here. All right, what do we got here? And nope, you guys are oh, that's what it is. Because I was thinking we were I knew we were only meeting twice that week. So in my head, if we were meeting twice, it had to be Tuesday and Thursday. But I forgot that week because of Martin Luther King, it's Wednesday and Friday. Fine, you get till Wednesday. Are you happy? I pushed it back in. Does someone have some argument of why now it's only due on Thursday or Friday? Let's just keep going. What else you guys got? Make me look stupid in front of everyone. I see how it is just because I can't count to 5. All right. But yes, you are correct. Congratulations. It is M5 is on next Wednesday. So you have till next Wednesday at 1700. I'm going to make everything else due early just so I feel like I won. Okay. So then going back to the files where we were. So I'm going to close this. The other thing I wanted to show you guys in here, if you hadn't seen it, was under the class materials. Good grief, Teams is slow. I mean, it's a great tool, and I have nothing against it. If you go to the R tutorial videos, I am populating this as quickly as I can with videos to get you guys up and running. These are all a little bit longer, like 10 to 15 minutes, because it's showing you how to install. This right here is a good one to show you how to download and then turn in what you're expected to turn in for your lab to make it easier. But I am going to start posting shorter, like 5-minute videos for functions in R, just to say, here's how you use this function. Here's a common function, because that was one of the feedback we got last semester was people were a little confused with some of the code because they hadn't seen it before. So I'm going to make videos with all of that. That being said, I will also tell you, I think I have this up here. Let me just post this in the chat. So I just posted in the chat. That's a link. I am also trying to post all of these videos to a Math 356 YouTube channel, just because a lot of people find that easier to track and go to, so you don't have to deal with Teams. I haven't started putting up there, but I'm going to try to also start posting at least one version of each of our lessons up there. Not necessarily M2. I teach M1, 2, 3, whichever one I think was the best version. I'll try to upload a version of that class video to there so you guys can watch that. And we'll see. Hopefully that YouTube channel continues to be useful. If there's something you guys want to see or it's not working, let me know. I'm always curious. Like I was telling the last section, every time I upload a video, it makes me mark whether or not it's appropriate for children. And I almost marked no on there because I was like, well, this is like college math. Children won't. And then my wife was like, no, they're asking you if it's like vulgar or nudity or something like that. She's like, you're going to get fired if you start making videos for your cadets that you're marking as inappropriate for children. So I was like, oh, okay. I guess. And I thought statistics was inappropriate for children, but that's not what they meant. So hopefully if I won't get blocked or taken down. But that is all I got. We are at time. So get out of here. Try to find some time to look at that lab just so you can kind of get an idea of what questions you have and how long it might take you to do it. But in the meantime, leave, don't come back till Wednesday. Try to spend some of the next 48 hours not thinking about me or math. And then we will reconvene then and start to get into some actual probability stuff, which is fun, in my opinion. Probably no one else's, but it is. Anyway, I will see you guys then. And I will send out to who my new 3 cadets on camera are for Wednesday. And otherwise, I will talk to you on Wednesday, if not earlier. Have a great week if you can. If not, sorry, try again next week.
Thank you, sir.
Yep.